Okay, well, all of you are fairly familiar faces, so let's, I've already marked everybody here, so perfect attendance, way to go. We're starting off with just the 5 of us, and I guess we could add 1 or 2 more, but not probably very likely. And let's see. Are any of you familiar with the new Blackboard? I know 2 of you are because you've been here before. You were here Thursday. The new Blackboard, I think it logs on the same as the old one did, but this is how it looks, or something somewhat similar to this. Whereas before, if you remember, you had a bunch of tabs down here, and then it had somewhere one of those tabs was syllabus and course information, another one was instructor information, another one was other things. And you almost had to know what was hiding where, or you had to just choose a bunch of different tabs and see if you found what you're looking for. We've done away with the tabs and everything's just right over there, okay? And I believe you do access it the same way you did before. That's what I've been told by other students. So let's go over the syllabus today. Since all of you have been here before, you've heard most of what I say about the syllabus, so let's just go over it fairly quickly and make sure I answer any questions you may have. So let's get started on the syllabus. Now, I don't like teaching off a Blackboard, but I wanted to show you what it looked like because it is new this time. Now, before, we would have clicked on this and it opened the syllabus. It doesn't do that anymore, or at least students in the last class said. You have to go over through the 3 dots here and click on that, and then I don't think you can edit the file or delete the file. I hope you can't, okay? But you can download the original file, and that's what I'll be doing here. And this, again, takes forever. Microsoft is slow in its own right. Blackboard is slow in its own right. And they, when you intermingle their slowness, it really slows down, okay? It's pretty bad. And a lot of times it gets hung up somewhere here, and then I have to do some other things to try to yank its chain. Like right there, it's not doing anything. The dots are not going across the page like they were. So here's what I do. Oops, maybe it is going to do something. Once you see the icon down here, there's a good chance, well, nope. Here we go and click on it and see what happens. Nothing. I'll click on it again. Ah, there it comes. All right, I'm going to enable editing here. Hopefully you won't be able to enable editing, but I will, because I do know there's a couple things that are going to change. Okay. You've heard me talk about syllabi before, so I'll just hit the new stuff. This is Math 227, 4-credit hour course, just like Math Calculus 1 and Calculus 2. We meet Monday and Wednesday, 12:30 to 2:10. You're on the right campus right now. Here's my information, same as always. Reminding you, same as always, if you are going to call me during office hours. Don't call me when I'm in class. I'll never hear it ring, and I may never get the message. Sorry. My voicemail just seems not to work well. Okay, so I don't know if anyone else's does or not, but mine doesn't seem to work well. And it actually looks like a period there. I guess that's a dash, okay. And so only call during office hours, and then if you don't get me during office hours, hang up and call back a little bit later. I may have gone down to the restroom, had to go down the hall for something, whatever, okay? My number here on this campus is 929-3449, and y'all do know we have to dial 205 first, right? Okay, so don't forget to do that. And only call during office hours, but don't bother leaving a message. If you can't get me, try again later. Or email me. Now, right now, I'm pretty far behind in emails, too. because ever since registration started, I have had maybe an average of 15 to 20 minutes to check emails, and I'm well behind on those. On Friday, I'm on the Birmingham West Campus, the academic building, which is the B building, 122, which is Dr. Pruitt's office. When you go in the door, you'll see Rose Saxon's desk, his secretary. Behind her desk is the copy room. That's where I am on Fridays. His is the big office in the corner. This is the number in that office, 6409. However, that is not my telephone. It is not my number. If I'm in there, I answer the phone. But if I'm not in there and it goes to voicemail, it goes to the grant coordinator's voicemail, not mine. I'll never give those messages. Okay? So don't bother leaving a message there. Only call during office hours on Friday. Okay, what are my office hours? Mondays, 8 to 10, 3:45 to 6. The biggest collective group of office hours I have all week. This is 4 hours and 15 minutes. Fridays are 4 hours. Okay. Tuesdays and Thursdays. Okay. I have almost always in the office by 8 o'clock. Soon after 8 if there's been a problem or something. So I'll get there as soon as I can, usually before 8. And Tuesdays and Thursdays, I'm only there 8 to 8:30 because I have an 8:30 pre-calculus algebra class, a 10 o'clock pre-calculus trig class, a 11:30 linear algebra class. A couple of you know about that one, and then a 1:15 first mini term physical science 111, second mini term physical science 112. Those classes, because they're mini term, 3.5 hours of class, 2 hours allowed, 4.5 hours in here at a time. Usually I'll take a little break. That's why it's 1:15 to 5:45. So no office hours there. List 8 to 8:30, and then 12:45 to 1:15. That's also my lunch hour, 15 minutes. 45 minutes. But I bring my lunch most of the time. I eat in my office, so always, and you can catch me there too. Now Wednesdays look a lot like Mondays, except for one major exception. 8 to 10 I'm free, and then I've got a 10 o'clock class, Cal 1, and when that's over over at 11:40, so I have 11:45 until 12:30. Again, that's my lunch, 45 minutes. And by the way, this was a lunch 30 minutes, sorry about that. This is lunch 45 minutes. Then after this, we start at 12:30. Then I have the differential equations class that starts at 3:30, I believe it is. We're at 12:30 to 2:10, and then we're 2:10 to 3:45. But as soon as that differential equation class is over with, I'm heading down to my office just to swap out books. No time to be in the office because I'll leave to go to the Birmingham East Campus for a physics class, 4:30 to 6:30. So I have almost no office hours after 12:30. Thursdays, same as Tuesdays, and then Fridays, 8 to 12. So usually there a little before 8 and almost always there at 12. However, this Friday I will not be on the Birmingham campus. My wife and I have to go over to Georgia to take care of some business there, so I will not be on campus Friday at all. All right, any questions so far? All right, the course description. Okay. All right. Sounds a lot like the first two. This is the third of 3 courses in the basic calculus sequence. Topics include vector functions, hang on to that notion, functions in 2 or more variables, hang on to that one, partial derivatives, including applications, quadratic surfaces, multiple integration, and vector calculus. Now that includes Green's theorem, curl and divergence theorems, surface integrals, and Stokes' theorem. Prerequisite, All of you had it, Math 126, Cal 2, and we're all here for Cal 3. Now, stop there. Okay, required text, same as you had for the first two. And by the way, I was mentioning this to Jonah, he's in a different book. They started what I wish we had done at the very beginning. Larson and Edwards also wrote Calculus Early Transcendental Functions, and they're in the 7th edition. I wish we had done it because if you remember back, we had to throw in chapter 5 after we had done 1 through 4 to cover early transcendentals. The other text embeds them in the chapters. So that's why we went with that. It's just so much easier to teach that way, and it makes more sense that way. Okay. So anyway, this same book as y'all have used before, but a different book. Starting this term, we'll step through until everybody's in that other book, and then we won't use this one anymore. All right. This is a 2018 text, meaning it will only be good for another year or two, probably. You can go through Cengage Unlimited. Now, if you go through that, you have to do it every term, unless you did the 2 or 4 term option on it, which most people don't. But anyway, the rest of this is all talking about Cengage, and to me, this is advertisement, and it doesn't belong in the syllabus, but they make us put it there. So anyway, here is all that mess. There are the other courses we teach here at Lawson that use Cengage text. So if you're in any one or more of these with this one, that same $119 or whatever it is, covers all your text. Okay? Now, there's the other options, and I don't know how those work, but probably very similar to this one. They say don't throw away your receipt because that has some sort of code on it you need to access things. All right. Now we get back to the regular syllabus. Blackboard. You heard me like about the way they worded that, so any questions? Okay. Professional competencies and objectives, student learning outcomes, that kind of stuff. Let me get as much of this shown as possible. All right. So your student learning outcomes. Now, I'm changing this a little bit because I had all of y'all last term with Cal 2, right? We didn't get quite as far in Cal 2 as I wanted to, so I'm going to expand this a little bit. Okay? You'll notice that I did put down here 10.3 because that's where my mark was that we left off last time. Is that right? Okay. So we'll start with 10.3 and do parametric equations and calculus. And that's what this is. I was changing this at home last night, didn't have my text with me, so I didn't know the section titles. So this is parametric equations and calculus. Okay? Then chapter 11, that's all we're going to do in 10.2. We weren't going to do polar coordinates and polar graphs. Whoops. Go back. Okay. And that was 10.4. 10.5 was area and arc length and polar coordinates. We weren't going to do that. 10.6 was polar equations of conics and Kepler's laws. Now, by the way, some good potential paper topics here. Just because we're not covering it, it's in the book, you can do it. For instance, who in the world was Kepler? Johannes Kepler. And what difference does that make? I see on that same page, Halley's Comet. You know, how does that use calculus? Anyway, we're not covering those, but you can use those kind of ideas for paper topics. Chapter 11, and some of these chapters sound similar, but they are somewhat different. This is vectors. Whoops. Okay. and the geometry of space. Okay. Now, I probably need to go back and just mention that before we start with quadrant surfaces. Okay. Now, so I may not change the student learning outcomes. That's the major, but we will be covering 10.3 and then chapter 11. 11.6 is quadrant surfaces. So we'll do all of 11 and then at 11.6, where technically this course usually begins. Chapter 12 is vector value functions. Chapter 13 is functions of several variables. If you remember that, that was mentioned in the course description, as was quadrant surfaces. They weren't in this order, but they are here. Vector valued functions, functions of several variables, multiple integration, that was mentioned, and then vector analysis, that incorporates all the other stuff, Stokes' theorem, Perlin divergence, surface integrals, those kinds of things. Now, are we going to get all that covered? The odds are probably no. I'm not sure we'll get into 15 at all, not with having to pick up where we left off at 10.3. But we'll get as much covered as we can. Now, as before, do y'all prefer in-class tests or take-home tests? Oh, really? Yeah, that's right. Y'all were a weird class. No, okay, got it. Oh, and by the way, I forgot to mention the writing competency research paper. That's included. Okay. So how do I grade you? Same as before. Your paper is required. It will be a test grade. Now, 10.3 I'll incorporate in chapter 11. So 10.3 and all of 11. That will be first test. Then chapter 12, then 13, 14, and however far we get. Imagine we're going to stop somewhere in 14. We'll see. Lois, your paper grade cannot be dropped, but the test grades, any of the middle test grades, the last test you have to take, because that's going to be accumulating everything that we done up to that. Won't be a comprehensive test, but all calculus builds on itself. So what you do in chapter 15 depends on what you learned in the earlier chapters and so on, stepping back as far as you want to. So the final chapter test, that is not dropped, but I will drop your lowest test score if it helps your average. Okay? At the end, your 90s are A's, 80s are B's, 70s are C's. Don't go down here. You've already heard all that. And the silly way they phrased this that I changed. Attendance, try to be here every class. I do record all the classes, but try asking a YouTube video a question. They usually don't answer. So try to be here so you can get the most out of the course. And you've heard all about withdrawal. It's far better to, I think, withdraw than make a D or an F. Okay, I don't think any of you should be making D's or F's, so I'm not anticipating that. But if something were to happen and you can't possibly, getting impossibly far behind, better to withdraw than get a D or F. I can't imagine too much about makeup work because of take-home tests, so how do you make that up? If you're not here when I give the test, next day you come in, I'll give you your test. Now, if you are going to be out of town or something like that, I can email you your test, but they usually don't come across quite as nice as a copy. So try to get your test in within a week if possible, but definitely before I give the next test, because then you may be making the same mistake in the subsequent test that you made in the previous one, but you haven't turned it in yet, so you won't know, I won't know that you're making that error. So please try to get them in within a week, or definitely before I pass out the next test, or before I pass out. Okay. We're going to try to start right at 12:30. As you notice, I have 45-minute lunch, and this time I had a student whose first time on this campus, and this building is not an easy building to navigate, as you've learned. if you remember that far back. But she didn't know where she parked. I mean, she knew where she parked, but she didn't know how to get there from here, okay? And she was trying to explain to me, so I took her to this. No, that's not it. How about this? No, that's not it. How about this? Okay, yeah, this somewhere here is where I parked. So sometimes things delay me, but I'll try to get started right at 12:30. All right, so you've seen and heard this before. Summarizing again. Plagiarism, don't do it. Cheating, don't do it. Professional decorum, I hate to say this, but it almost seems like a waste of words, okay? You know, I'm not anticipating any issue with any of you on any of this. Now, if you need to rehydrate, rehydrate. I don't care if you drink or not. But if you do make a mess, you're going to clean it up, right? That's what I think about that. Inappropriate clothing, I can't imagine any of you in any of that, but don't do it if you were thinking of it. Okay. Course concerns, that was all stuff we're expecting of you. This is stuff you can reasonably expect of us. If you don't feel like I'm giving you a good shake, paying attention to what your needs or your questions or your issues are, then please come see me, and we'll try to straighten it out one-on-one, okay? If that doesn't work, we'll go to the department chair. Oh, that's me, okay? And we'll work it out. I'll write myself up as necessary, okay? After that, Dr. Pruitt's next. I'm in his office every Friday morning that I'm there, so he can chew me out there as much as he wants. After him, Dr. Davis, the academic dean, Vice President Dr. Crawford, President Dr. Ward. We'll take it as far, but start at the source. Start with me, and we'll work our way up if necessary. Okay, discrimination, harassment, you've all heard me talk about that. I include bullying there. Let's make sure it doesn't happen. Let me know if you even sense that there could be something going on. Because most of the time, no one's going to do it in front of me, okay? But they may in front of you, or you may hear about it. So let me know. Let any of us know. Americans with disabilities, as you know, I'm hard of hearing, so I'm sort of sensitive to this. Please let Dr. Renee Herndon on this campus, Ms. Janine McCoy-Jones on the Birmingham campus. And then the college calendar, course calendar, academic calendar it's sometimes called. Classes started last Thursday. That's when drop-ads began. Even though on the calendar it says the 15th, we have to sit at the help desk on the 16th, Thursday, so I assume you can still drop ads then. Doesn't make any sense for us to be sitting on the help desk if you can't drop ads. But I don't know what they're doing there. Next Monday is Martin Luther King Day, which is sort of one of those good news, bad news situations. The good news is it gives us a chance to honor and celebrate Dr. King's birth and life and accomplishments. But the bad news is you miss class. Okay? Get over it. We'll try to make up as much as we can. Okay? Now, when I was talking about withdrawing, this is not the withdrawing I was talking about. This is what if your family has to move. You're not possibly going to be able to finish the term. If you know that, find out before January 31st, then you can withdraw completely from the term with and get a partial refund. That's a complete withdrawal from school. Okay? After that, nothing happening big in February. In March, the first week of March is midterm, so the next Monday after that is the midterm progress reports, and that's where I submit if any of you have D's or F's at midterm, which I don't anticipate any of you need to be doing unless you haven't turned in your work, which could happen. But don't let it happen. The week after that, in fact, Friday of that week, we hit the midterm, we hit the 60% completion date. What that means, if you find out you are going to withdraw from a course, not the whole term, from a course, and you're on any type of federal financial assistance, that Pell Grant, VA, something like that, and many of the scholarships are probably this way too, but if you are on that, if you withdraw before that 60% completion date, it's Friday the 13th of March, you owe the money back. Okay? If you know you're going to have to withdraw, you're getting hopeless behind, can't possibly pull out the D or an F, anything above a D or an F, then, and if you want to, if you wait till after this date, but before the 20th of April. So you've got more than a month, 5 weeks in fact, that you can, more than 5 weeks, that you can withdraw. Anything after this date, you're not withdrawing. You're going to get your score, whatever it is. Okay, spring break is the 23rd to the 27th of March. Last day to withdraw is the 20th. Final exams are 10 days later, and final grade reports then, and spring commencement exercises. I take it some of you might be graduating this term? You, others? Not, okay. So nothing real special there, except that I have to have your grades in by Thursday before you graduate from Friday. Okay. So that means get me that final exam as soon as you can, so I can get your grades done. The others, no problem. All right, any questions on that? Now, I can't remember, did I make all the, I don't think I'll change anything in the student learning outcomes. I've changed those two titles, so this will be good. I think it'll be good. I just remembered, this is something really awkward about Blackboard. You can make changes here, and it leaves the old one in there. And I have to do a bit of mess to go back and get them to change. So anyway, once I do get those changes made, if you will, then sign and date, or you can print this page, sign and date it, or you can fill it in and then email it to me. Either way you want to do it. This is once you've had all your questions answered. Any questions on the syllabus? None? Okay. Then let me get out of here. And I'm going to save this. What I'm going to do, I forgot to do this in my first class. By the way, before we get any further, remind me, I do have an announcement to make. I forgot to make it in my first class today. Okay. I'm going to save as. That makes it really awkward. Okay, go on, get out of this. Okay, now what I have to do, because I have to delete this file and then go back and upload the one I just saved. Okay, today's the 13th, that was 108, that's the one. And now it's uploaded the one I just made the changes to. All right, any questions on syllabus? You can fill out that form and email it or bring it to me anytime. Locator card, again, awkward the way we have to do this. Have to download the original. And I think y'all have to do this too. You can't just click on it and it opens. You have to download it. But then you can't delete or edit the file. Okay. All right. the top information is the same, spring 2020. My name, my phone numbers on both campuses, email address, my department, and all right, here's pretty much my week. Mondays, 8 to 10, office hours. Okay, Cal 1, 10 to 11:40, lunch from 11:45 to 12:30. So I'm in my office. You can come see me, email me, whatever then. This class, 12:30 until 2:10, 2:15. Back in the office to swap out books, 2:30. Differential equations, that goes until 3:45, and from 3:45 until 6, I'm in the office pretty much. Tuesday and Thursday, identical. I'm in the office from 8 to 8:30, both days. Pre-calculus algebra, 8:30 to 9:45. Pre-calculus trig, 10 to 11:15. Linear algebra from 11:30 to 12:45, and then from 12:45 to 1:15, that's my lunch. 30 minutes, both days. And first mini term of Physical Science 111, and second mini term Physical Science 112. The last term, the 112 started later. This term starts at the same time. It's 2.5 hours class, 2 hours lab, and then off campus after 6. As soon after 6 as I can get off anyway. Wednesday, a little different from Monday. Same 8 to 10 office hours, same Cal 1, same lunch, same Cal 3, and same differential equations. The difference is as soon as that differential equations are through at 3:45, then back to the office. Not really much time there, just to swap out these books, pick up the books for my physics class, and head to the Birmingham East Campus. And there I am. It's the nursing building, in room K103, and that's my physics class. It's the physics class for the DMS, Diagnostic Medical Sonography majors, and I'm there from 4:30 to 6:30. Usually I'm off campus between 6:30 and 7. Then Friday, Birmingham West Campus Academic Building, B122, from 8 to 12. Now, I list a lunch here. Usually I eat a snack or something, but not a full lunch. This Friday, not on Birmingham campus. I'm taking 4 hours personal leave, then we've got to go to Georgia. Any questions? That's my locator card for this term. All right. And again, you see all these things just like this. Research paper instructions. You've seen these before. You should know them by heart by now. Let me just point out a couple of maybe slightly different things from what you've had before. If you had a course under me last spring, this will be the same. But if you didn't, the only thing here is, does anyone need me to go over this again? You remember what's going on with it? Okay? So, the only difference is, if you submit your paper this month, the month of January, you get 4 bonus points. In the month of February, you get 3. March, you get 2. The first 3 weeks of April, you get 1. The reason for that is before April's over with, we're starting final exams. So that's why I give you 3 weeks in April to get that last bonus point. That last week in April, you just get your score. Okay? Any questions? And remember to submit a single page from one of your sources. Any questions? Remember it pretty much from before? Okay. Now, web assigned class code. The guy, WebAssign, got all this stuff to me before December was over with, so I have these available now. Usually he's into the next term before he ever gets them to me. But for this course, now you don't need fast key, that's just what they call it. Here is the course code. Lawson.al space 5555 space 7122. That and your whatever code you get on your receipt or whatever, however you do that kind of stuff. This gives you the ebook. It gets you WebAssign. Now, I'm not going to make any assignments in WebAssign, but they're all out there. The things are there. If you want extra practice, and WebAssign has pretty good tutorial services that come with it, so you can use that to your advantage if you wish. I won't be assigning any. This is only for your benefit. Okay? Any questions on that? Okay. Next are your PowerPoints. Okay. You hit that level because this is a folder. You hit that arrow and it opens up the folder. So we'll be starting in 3 and then do all 6 sections in 11. Then I can't remember how many sections are in 12. 5 sections in 12. A bunch of sections in 13. We won't do them all, but I did put them all out there. Then 10 sections in 13. We won't do them all, but they'll all be there if you want to look at them. In 14, another big number of sections. At least 8 sections in 14. We won't do all those either. And then 15, if we get time and can do it, no more than 8 sections there either. Okay. So lots of sections. I guarantee you we're not going to be able to do them all. All right. Just to keep from taking up so much space here, I'll close that folder. Everything comes up from the top. So those are your PowerPoints. Here are the YouTube videos. This is a little easier to do this. All you do is click on it and it opens them. It may take a little bit. And you remember how the YouTube videos go. The stuff at the top is the oldest stuff and the stuff at the bottom is the newer. There was one section a few years ago, it was like pulling teeth getting things covered in that class, and we actually started 227 back in 8.3, okay? So I left these on here in case you want to review them for any reasons. But generally, we will be starting, and there's 10.3. May replace that one today, or maybe next time, we'll see. But what today's will be entitled is Syllabus. So once I load the one from today, I will take off. All that other is much earlier terms. This is where, well, this term stuff will start at the bottom. And last term we got to 4.2 and 14.2 and 14.4, but not any further. That's why I left these others at the top. So if we do get further, it's all there. All right. Any questions on YouTube videos? Now the other things are links as well. This is several sites that I've either run across or people have told me about. Visual Site Calculus. If I'm not mistaken, this is an earlier edition of this text. They didn't have the most current one. If you can find the more current one, let me know and I'll update that. Education portal, I think, also references an earlier version. Prof. Rob Bob, he's sort of a little goofy at times, but he's okay. And Slater, again, uses an earlier version of the text. If you can find that Slater has updated this, let me know. I'll go and check. But last time I looked, he was still in the older version. I think it takes them a while to get the new version and get everything done. All right, any questions? And again, all these links, you just click on this, it takes you straight to the link. So a lot easier than the files, okay? The PowerPoints, I think once you click on the PowerPoint, I think it takes you straight there. I don't think you have to go through the 3 dots. Okay, any questions then on any of that? Okay, and that also shows you how the new Blackboard looks. By the way, the name for it is Blackboard Ultra. I don't know what's very ultra about it, but that's what they named it. Okay, that done. I guess the next thing we're going to do is, I think I'll leave this open because the differential equation class, I won't have to open it again. The next issue is safety. I think all of you have heard safety probably until you can repeat it yourselves, right? Any question? Anything you're a little fuzzy on? What 3 areas of safety do we always want to keep in mind? Weather, and boy, Saturday was a reminder of that, okay? And they actually did close the school here at 11, I think, because the weather was pretty severe. What's next? Fire or some sort of internal issue like chemical spell fire or something like that. And the third one, active shooter. Any questions on any of those? If you don't remember what the procedures were, we can go over them really quickly. Anybody? No questions? Consider safety done? Okay. Now, rather than going back through Blackboard, I'm going to do the rest of this through my flash drive because it tends to be a lot faster than Blackboard. And didn't I tell you to remind me? Okay. This is not good. I have a cap somewhere here for my flash drive that is now missing. Don't know where it is. So I'll have to look for that later. All right, finally I got that plugged in. All right, we're still recording. All right, and we're beginning today in 10.3. All right, and the announcement you keep forgetting to tell me about is this one. Coming up, it's a ways off. I was thinking it was January 12th. I'm sorry, this is January 13th, so it wouldn't have been this. This is February 12th, so you got lots of time for this one. I'll be announcing it basically, and asking if you remember. But anyway, coming up February 12th, 9:30 to 11:30 on the Birmingham campus, the B Building Academic Hall. And then on Thursday the 13th, 9:30 to 11:30, same times. On this campus, in the probably what they mean by that is faculty staff dining hall. They say campus cafeteria. They may be in the whole cafeteria. My guess is they're going to be in the campus, the faculty staff dining hall. But the individual institutions that have been invited to attend include AUM, University of Alabama, UAB School of Health Professions, Mississippi State. Well, you can read these. Tons and tons of schools. Mostly from the state of Alabama, but not all. Okay. Georgia Southwestern State University, William Carey University. There's from all over the place here. Okay. Kentucky State University, Tennessee State University, so Alcorn State. So lots of different schools will be here. Birmingham campus Wednesday, February 12th. This campus Thursday the 13th. All right. Any questions on anything before we get to calculus? Okay, let me get my slideshow set up from the current slide. Okay. Now, Chapter 10, if you recall, was conics, parametric equations, and polar coordinates. We didn't do anything with conics, only with parametric equations. 10.1 was conics, 10.2 and 10.3 were parametric equations, 10.4 and 5 and I think maybe 6 were polar coordinates. So we're just doing the second one of parametric equations, 10.3, parametric equations in calculus. Now, what I want you to do, if you can remember this, here are the objectives of this section. Find the slope of a tangent line to a curve given by a set of parametric equations, as opposed y is a function of x, but a set of parametric equations. Find the arc length of a curve given the set of parametric equations, and find the area of a surface of revolution when you're given that in parametric form. So let's start with slope and tangent lines. Now the thing I want to find out from you, if you recall, did we do any of this last term? I have a mark coming up on the next page, but that could have been from an earlier term. Do you recall that we did any of these? No? Okay, good place to start then. All right. No questions before we get going. Now, from this point on, I don't see my time on the computer screen anymore. It's covered by the thing here, so my battery died in my watch, so I will keep talking forever unless someone stops me. And we stop at 2:10? Okay, so if y'all will keep up with that, I'd appreciate it. So, let's consider a projectile represented by these two parametric equations. X is equal to 24 times root 2t. I really don't like writing it this way because now this in print is pretty clear. The root 2, that square root sign, stops at the 2, the t is outside. But you know, it's still a little, so it could be a little ambiguous, especially if you were writing this by hand and you couldn't tell whether that included the t or not. So I would write this 24t times root 2, okay? Just because it's absolutely clear what you're doing. Okay, so that's your x parametric equation. Your y parametric equation is y is equal to minus 16t squared plus 24 root 2t. Okay, and again, the t is outside the radical sign, so I would have written this 24t times root 2. It's a little awkward sounding, but it at least keeps you from misplacing the t. Okay. Now, I know at least one of you hasn't had any physics, but all the rest of you have, right? Okay. This, you should recognize this is your standard projectile two-dimensional motion. What gives it away is minus 16t squared. That's exactly 1/2 of your acceleration due to gravity in U.S. customary form. That's minus 32 feet per second squared. Half of that is minus 16 t squared. This then would be the y component of your velocity, because that's what's multiplied by t. When you see these are identical here, that tells you got a 45-degree angle, which is exactly what you have here. Okay? And the component, the initial velocity here, you could back up a little bit and come out exactly what that is. I'm thinking right now it's 48 feet per second. Okay? I don't know that for sure, but just doing it quickly in my head, I think that's the case. Because if you multiply that by either cosine 45 or sine 45, it's root 2 over 2. 2 will go into 48 24 times, and you got root 2 there. Yeah, so I'm pretty sure that was 48. So here is the situation here, shown in this figure. Know that these equations enable you to locate the position of the projectile at any given time. If you know the time, you know exactly the xy coordinates of that projectile. Okay. Now, I'm not entirely sure why they included theta here. Theta is not in any of our formulas or equations. We knew initial theta, theta naught, was 45. This is for any theta. It certainly is something that's good to know or useful to know, but if at this point here, whatever time it took for you to get to here, which looks to be about 27 to 28 of the x value, you can back that out and find out what your t value was. But whatever time put you here, now the angle is from the horizontal to the tangent line here. That's your angle theta. Obviously not as great as 45 because the acceleration due to gravity is pulling it downwards, so therefore it's decreasing until it reaches that point where it's a horizontal slope, and then it starts being a negative angle past that. So anyway, at any time t, the angle of elevation for the projectile is theta. So nothing we've dealt with here indicates that's anything that's super important here. You also know that the object is initially projected at an angle of 45 degrees. The reason you knew that was your two components of your x and y components of velocity were identical, so it had to be 45 degrees. And the slope at that angle 45 degrees, so your initial slope here was 1. Later it's going to be less than 1 based on that angle theta. Way too much information perhaps, but that's what we know so far. But how can you find the slope at some other time t? Okay, that's where the theta comes in, because the tangent of theta will be the slope. Okay, tangent of 45 is 1. At some later time, it's going to be the tangent of whatever angle that is. The next theorem answers this question by giving a formula for the slope of the tangent line as a function of t. And this is on page 710 in your text, if you have your text. Okay. By the way, I just sort of dawned on me. If way back when you took Cal 1 or last term when you took Cal 2, if you happen to buy the $8 or so loose leaf thing, is that what you remember? If you did the Cengage Unlimited? Oh, you didn't do that. Okay. You just bought the book. Okay. But even if you had done Cengage Unlimited and bought the book for a fairly cheap price then, I'm not going to use Cengage Unlimited. I'm not going to use the WebAssign. You could use it if you wanted to. You can renew all that. But if you had the book, it just dawned on me when I saw yours there. If you bought it before, you didn't have to turn that one back, right? That was photocopy. So without paying anything else, you have that book, and that's all I teach from. Okay, but anyway, this was page 710 in the old text. Okay? Here's the theorem. Parametric form of the derivative. If a smooth curve C, capital C is usually the indicator of a smooth curve, is given by some two parametric equations, x equals some f of t, remember that was the 24t root 2, yeah, that was your x, and y was minus 32t, well, minus 32t squared plus 24t root 2, however you want to phrase that. There are any two independent functions of your x and your y, functions of time. Then the slope of C at x and y, which happens to be at some common t, is this. Here's how you calculate the slope. And this was, I was thinking we did this before, but I couldn't remember for sure. I've taught the course many times. dy dx could be written as dy dt. In other words, that's g prime of t divided by dx dt, which was f prime of t. And that gives you the slope dy dt, dy dx. dy dt, easy to calculate if it's an agreeable function, divided by df dt, dx dt, okay? As long as this is not 0. Remember, where is that 0? That's 0 when it reaches the height of this, that parabolic curve. You can't calculate the dy dx there. Not defined. Well, it is defined. No, sorry, set it backwards. That's where dy dt would be 0. Dx dt, that would be if you had a vertical slope somewhere. And then you don't have a dy dt because you have a vertical. So that requires that dx dt not be 0. Okay. So here's example 1. Find dy dx. I've got to find my pen first. There it is. For the curve given by x is equal to, let me get my pen set up. Okay, x is equal to sine t, y is equal to cosine t. What is your dy dx? From the theorem we just had, what was that? Okay, he's jumping the gun on us here big time. Dy dt divided by dx dt. Now that sort of sounds like it makes sense, doesn't it? Your dt's cancel out, and you've got exactly that, right? They don't cancel out, but, you know, it looks like that makes sense, right? So we need to calculate what dy dt is and dx dt. So let's do dy dt first, and that would be what you said. Negative sine t, and the x dt is cosine t. So this would be minus sine t over cosine. I don't know where that came from. Over cosine t, which is, what's another name for that? Negative, say again? Negative tangent t, exactly. Now, that seems a little bizarre to say dy dx would give the answer in t. It almost would seem like that's looking for this to be some function of x. And before I go to any links to do that, let's see if that's indeed what the book says it should be. No, they leave it in terms of t. All right. So that's exactly that. Because dy dx is a function of t, you can use that theorem repeatedly to find higher order derivatives. So what do you think d2y dx squared? Okay, what would that be? Let's first sort of break it down a little bit. That would be d of what? Okay, which would be d by d, derivative of d by dx by x, right? This is what gives you d2y, and this gives you dx squared. So you could have written that here. I was afraid it might be a little confusing. But I think actually that's better. Let me go on and do it that way. Okay, that's exactly what d2y dx is. dx squared is. It's d by dx of this, right? What is d? But we already know what this is. That's minus tangent t, right? So this would be d by dx of minus tangent t. Okay? Now, that is, just like we did up here, d of minus tangent t, that's the dy dt, over, I'm sorry, well, over dx dt, okay? Now, if I'm getting too lost in the sauce here, this is hilarious. You right? Okay. Well, question, isn't this exactly what that is?
Yes.
Okay. And this thing right here, we just did it and found out that was minus tangent t, right? So this is d by dx of this thing here, which is minus tangent t. Now, let's just imagine that, remember this is d, let me write this. This is d by dt of y, right? That's what dy dt is dy dt. I'm sorry. dx, I'm sorry, I meant to put x. I realized just then that I put dt. dx, okay? That's exactly what that is. But before we did dy dt over dx dt. So now we do dy prime dt over dx dt. Because this is your y prime. This is this thing. And you do that over dx dt. The dt's go out, and you have exactly this form again. d by dx of that. Is that not true? Okay. Making sense? Okay. Well, now let's see what that is. What is d by dt of negative tangent t? Did anyone ever remember what your let's do it this way. Minus d tangent t dt over, but dx dt we've already done, that's cosine t, right? Say again? Derivative of tangent?
Well,
not quite. You're doing derivative of secant. What's the derivative of tangent? No. Derivative of tangent. Is it not? Come on, folks. Pretty important stuff. Over cosine t. Well, what is secant squared t, though? It's another name for that. What is secant squared? You know, they don't even do it. I mean, I thought they were doing the one from above. They're not. They were just saying in general. Sorry about that. I was doing. But what this is what did you just say it was?
I thought it was more of cosine
Cosine squared
squared.
times a 1 over cosine. And this would be minus 1 over cosine cubed t, which would be minus secant cubed t. Okay. That's a long way around to get it. Actually, where we should have stopped, I wasn't paying attention to the book, if we had just done this part here. And this is all they were doing. Okay. So, all right, for me to erase some of that? In fact, most of it. In fact, I'd say all of it. Nah, let's just erase some of it. I don't want to reproduce the wheel here. Okay. I was going back and doing the one they had just done, thinking that's what they were doing. They didn't. Now, they may come back to the next example and do it, but that wasn't what they were doing here. Okay. If we do that again, we'll remind ourselves what we just did. Okay. This was that, which is, I think it's just what I just had too, d of dy dx. That is an x there, it's an ugly x, dt over dx dt. Okay? Same principle of what we did before. This thing is exactly that. This is where you get your d2y over dx squared. So that's exactly what that's defined to be. And when you do this, just like we did before when we did dy dx, it's dy dt, d of dy dt dt, d of dy dx dt over dx dt. Okay? It's this thing, derivative of that with respect to t over dx with respect to t. Okay? And that's how they lifted the second derivative. Let's do the third derivative. d3y dx cubed would be d by dx of d2y dx squared, right? D by dx, pull that out, and that leaves you a d2y dx squared here. Or doing the other way, this is d3y over dx cubed. Okay? Now, what would that be? Doing the same thing we just did there. D by d2y dx squared by dt over dx dt. Okay? And that's exactly what they got. Okay. Now, any questions on those? Now, sorry, I've gotten kind of mixed up in the presentation here. Everybody got this? Let's go back and see how they did example 1, which is what we've already done. And that was, there's your x as a function of t, y as a function of t, Your dy dx is dy dt over dx dt, which was minus, just like Dawson had done, minus sine t over cosine t, which is minus tangent t. And then here's what we were just doing. And this is because dy dx is a function of t, you can use that same theorem before repeatedly to find higher order derivative, because this is d2y dt is d by dx is dx dy dt. Well, that is d of this with respect to t divided by d of this with respect to t. And that just gives you simply that. The third derivative is d of the second derivative with respect to t, x, okay? But then this is the d by dt of what's inside here divided by dx dt. You just always divide by dx. So there's your third derivative. Okay. And you can keep on climbing as many as you want to. So, with that in mind, they're skipping example 2. So let's go back and do example 2 here. For this curve, x is equal to the square root of t, y is equal to 1/4 t squared minus 4 for any t's greater than or equal to 0. All right. Just using half of our t's, the positive half. It says find the slope and the concavity at 2, 3. So we're looking for m of m at the point 2, 3. And we're also looking for concavity at 2, 3. Okay. Now, before we go any further, okay, I want to make sure this makes sense, okay? And what I mean by that is that when x is equal to 2, y had better be 3. Because otherwise this doesn't make any sense at all. Well, for x to be 2, what would t have to be? 4, okay? And if t is 4, then this would be 16 minus 4. 12 divided by 4 is 3. Yes, that makes sense. The problem is well posed. It makes sense. So we want the slope at that point to 3. We know that point exists. X equal to, y is equal to 3. So what gives us the slope? What is m? What is your slope always? It's what? It is a derivative. Which derivative? Of what? D dy dx. Exactly. Okay, so how do we get that slope, dy dx? What would that be?
I'm sorry, what did you say? I apologize.
I'm sorry?
What did you say?
Okay, how do we get dy dx?
It's about the y.
Divide what?
The y.
Ah, okay. dy dt over, here's your division, dx dt, okay? So now we're going to have to go back and figure out what those are. Now, when I first wrote it down, I didn't like it at all. Why not? Do you like to take derivatives of radicals? No. How is a better way? T to the 1/2. Perfect. Now I can do that one. This one was fairly easy. Let's do dy dt based on that. What is that? dy dt.
1/2 t times
Okay. Okay. If I'm understanding correctly, the y dt would be, if you multiply this through, this would be 1/4 t. Oh, you're doing the x part too. Okay, yeah. He's way too quick, isn't he? Okay. The y part here would be 1/4 of y squared. Derivative of that would be 1/2. 1/4 of t squared. Blah 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 blah. That would be 1/2 t. Right? Yay? Just the dy dt. Okay. Now let's do the dx dt. I think you had already done it. What was that? Okay. Now what does that give us? What does that give us?
Are they both 1/4?
No, they both had coefficients of 1/2, didn't they? T to the 3/2 power. Perfect. Okay? That's your slope. Now what t was it we were dealing with? T was what?
There's a 1/4 times 9 in that equation as well. Negative 9.
That's all the coefficients the constants stay zero. The regular number should stay zero.
Okay. I'm not sure I'm following everything. Are we okay now? Was there another question? Okay. So that's t to the 3/2. What t was it that gave us this point? Yeah, t equals 4. So what is 4 to the 3/2 power? Easy way to do that would be what? Deal with the denominator first. Square root of 4 is 2. And 2 cubed is 8. All right, there's your slope at that point. Okay, we didn't have to go back and get everything in x and y. Once we got the t's, we knew what t was going to produce that. Okay? All right. Now, there's the slope part. How about the concavity?
Just take the derivative again, right?
Okay, in other words, the second derivative. So d 2y dx squared. And break that down a little bit, and what's that? D by dx of
T to the...
okay, let's do dy dx. Okay, and then what you just said, this is t to the 3/2. But let's hang off just for a moment here, and let's do our d by dt of t to the dy dx. Yeah, t to the 3/2, right? Divided by say that one more time. Dx over dt. And probably okay. I'm going to back up just a little bit. And let me not do this that quickly. I mean, I know you said it, or I think you said it anyway, but let's just go on and write this as dy dx. Right? Look okay? Now, what this is then d by dt of t to the 3/2, because that's what we got last time, divided by, and what was our dx dt? Which we did last time too. One half t to the minus 1/2. right? Okay, so let's do what they tell us to there. What's d by dt of t to the 3 halves? 3 halves t to the 1 half over 1 half t to the negative 1 half, right? Now, here I can get rid of the 2's in the denominator, and that will leave me just the 3 as the coefficient part. Everybody agree with that? Okay. And what's t to the 1 half divided by t to the minus 1 half? T. Perfect. Perfect. And what t are we dealing with? 4. And so the concavity here, which is the second derivative when t is equal to 4, this would be 12. Okay. 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 Now, what does that concavity tell you? Up or down? Which is which? Yes, when it's positive. So this is definitely positive, so this is concave up. Okay. All right, good deal. All right. Now, since they didn't show example 2, we've worked out what it is, but they did show the graph of it. I'll let you find that in the book, okay? I'll give you a picture of it. Oh, man. This hurts. Okay. There is your function. It starts with t greater than 0, so we're only going to deal with positive x's and positive y's. Okay. Y's, not positive y's, positive t's. And that would make your x is always positive, except 0. Yeah. And your y, when t is equal to 0, this would be minus 1. So that's what we started down there. Okay. And there you have your t is equal to 4, the slope is equal to 8, and the concavity was way steep high, so that is a 12 positive fact. It was positive everywhere there. Okay. I think we're moving then to example 3. There was a little verbiage at the bottom of the page there, because the parametric equations x equal f of t and y is equal to g of t need not define y as a function of x. Quite often they won't. Yes?
Just listen, I guess, 7 minutes left. We have 7 minutes left.
7 minutes left, thanks. I was afraid we were getting short. These functions you could have written y as a function of x. The one I just showed is that. However, it is possible for a plane curve to loop around, cross itself, and do all sorts of things there, and that's what we're doing in example 3. A curve with 2 tangent lines at a given point. Okay? This is called a prolate cycloid, and it's given by x is equal to 2t minus pi sine t, and y is equal to 2 minus pi cosine t. Now, it crosses itself at the point 0, 2. Okay? How would you know that? There's no way right off the top to be able to just look at it and say, oh yeah, of course it crosses there. You'd actually have to start plugging in some points. Now, they don't tell you any limits on your t's, so Let's start with t equals 0. Where is your x in when t is equal to 0? Not quite. T is equal to 0, you get t times 0 is 0 minus pi times sine of 0. What's sine of 0? Sine of 0. Cosine of 0 is 1. Sine of 0 is 0. Okay, so this x would be 0. And when t is equal to 0, you have y is equal to 2 minus pi times cosine of 0 is 1. So 2 minus pi would be 2 minus pi. Okay? So x equals 0 and y would be 2 minus pi. Well, pi is 3.14, so blah, blah, blah. 2 minus that would be about a negative 1.1416. And that's just about what you get down here. So this is the place where t is equal to 0. For negative t's, you would have been going back this way. Positive t's, you'd be going that way. Okay. Now, that wasn't probably very helpful. That just gives you a starting point here, and just using their arrows, this is for greater, t's greater than 0, and these are t's less than 0 coming down to there. There is t equal to 0. Okay. Still doesn't indicate that you have that. So let's find the equations of both tangent lines at that point. Okay. So if you know at this point x equals 0, y is equal to 2. All right. Now, the easy one to start with here is y is equal to 2. What is going to give you a value of y is equal to 2? T equal what?
One. Let's go sine of 1 is 0.
Cosine of pi halves is 0. Okay. So that's what I thought you said. Okay. When t is equal to pi halves, then this is 0, so this would be a 2. Okay? So I'm guessing this would be this one. Okay? All right? Because there's your y is 2. What is another value for t that would give you y is equal to 2?
3 halves.
I believe you're probably right, but that's going to be somewhere out here, assuming that this is going up and coming back down. That would be somewhere here. I want somewhere, you see, this was for t just a little bit greater. We want t a little bit less than 0. What's the t on this side? The 0 for, yes, negative pi halves, right? Negative pi halves, cosine of negative pi halves is also 0. So this, I think, is that. All right, so now we got t equal positive pi halves, t is equal to negative pi halves. So that's what we're going to plug in here. Okay? At positive pi halves, this would be pi halves. Okay? And sine of pi halves is 1. And pi times 1 is pi. And pi halves minus pi is going to be negative pi halves. Okay? That was supposed to give us a 0, wasn't it? Let's go back and see if I got that right.
Wait, it was pi halves times 2, pi halves times 2, so wouldn't that just be pi?
Yeah, okay. Let's back up and do that again. For this to be 2 here, this has to be 0. Cosine of pi, which we were doing first, negative pi, no, pi halves. That would be 2 minus,
I think you multiplied, when you said 2 times pi halves, you said it'd be pi halves.
right,
But then 2 times pi halves just pi.
okay, yeah,
So
I'm
two
sorry.
cancel out.
When t is equal to pi halves, this gives you 2, right? Because cosine of pi halves is 0. And so this would be 2. So cosine of pi halves. Sine of pi halves is 1. And this would be pi halves. So this would be pi minus pi is 0. Right?
Yeah.
Okay. Pi minus pi is 0. So sure enough, this is when t, this one is when t is positive pi halves. This one over here is where t is minus pi halves.
We're out of time.
We're out of time. Okay. Thank you so much. Okay. We'll go back and do that. Remember, remind me next time, the 2 points in question are pi halves, t is equal to pi halves, and t is equal to minus pi halves. I think we verified those. And then we'll find the equations of the tangent lines at those points. All right, let's see. Did we get enough done to have any homework exercises? Whoa, this is a short section, isn't it? I think you can do number 5 or 7. Ah, there's my thing. You can do either 5 or 7. 5, they're both at Calc Chat. 5's at Calc View. You can do any of the odds 9 through 17. They're all at Calc Chat. 13's at Calc View. And then we'll wait until we do the next exercise, finish that one before we do 19 and 21. All right, good deal. Alrighty, some homework exercises. This is going to be a good course, isn't it? Yes. Okay.